off the beginning. So here's what I'm talking about. Speed, velocity, distance, displacement. Right? If we're dealing with speed, I'm going to keep that in red, versus velocity. Now from the background you probably already know that velocity has direction. I care about direction. But speed, I don't care. Just give me however far I've gone, whatever distance I've gone, put that over time, bada bing, bada boom, you get a speed. Now specifically this is an average speed because I don't know if you sped up, slowed down, or that fluctuated, but that's fine. If we want to look at velocity though, velocity we need displacement over time. Slightly different. Now if you're going in one direction, if I started here, let's do that in blue. If I started here, went this way, ended here, so start, end, and you went this way. Your distance and displacement, well, the same thing, right? How far are you away from the start? If you only go one direction, that's going to be the same. But if you say you went this way, then you went that way, then actually you ended up over here, a little bit farther away. For distance, maybe you went 50 total meters as you went there and then back and then forward again. Say you went 50 total meters and you did that in, 4 seconds, right? Your average speed is going to be 12.5 meters per second on average, right? That's your speed, specifically your average speed. Your displacement, though, right, is just from start to finish. So maybe you overlapped a part here, but that displacement, let's say you're only 40 meters away from where you started. But I got to do that in a different color. I got to do that in green. Color coordinated, Mr. J. Get it together. All right, let's say that's 40 minutes, and that's your displacement. 40 minutes. 40 meters, that's your displacement. So you're 40 meters away. Again, you did that in 4 seconds. So your average velocity, right, V average velocity, is going to be 10 meters per second. Because you kind of dilly-dallied here and went backwards and then forwards again. But for the whole trip, I don't care about the path you took. I don't care how you got there. For the whole trip, you're 40 meters away from where you started. You did that in 4 seconds. Average velocity, 10 meters per second. Cool? All right, level 1. Level 2, what if, let's say, I can move this whole thing. That is super satisfying. Let's say you started here, you went this way to the store, got the stuff that you wanted, and then, went all the way back home. Full trip. So, round trip speed, again, the average speed, distance over time, right? Distance, time. So let's say the distance you went all the way there and back, that was 50 this way, 50 that way. Let's say, I'm making up these numbers. So 50 plus 50, 100 meters total. You did that in 10 seconds. You're a little slower on the way home. All right, and now that's, okay, 10 meters per second. I don't care that you also went backwards. I don't care that your path changed. Total distance, total time. All right, gives me your speed. If I'm looking at your velocity, all right, now velocity, again, we're looking at displacement over time. Displacement. Now another way to write displacement is a change in a position. So this happens to be horizontal. So I'm going to say a change in the horizontal position, the delta x. This means change. So change in x over time. Now if I started here, went over there, ended up back right where I started, what's my change in position? If you said a big fat whopping 0, you would be correct. But it doesn't matter how long it took. It took 10 seconds, but it doesn't matter. My average velocity for this is 0 meters per second because I'm right back where I started. Again, velocity and displacement, I don't care how you got there. I don't care about the path. You could go 6 ways from Sunday and do all of this. It doesn't matter, right? What we care about is where are you from where you started. So final position minus initial position. Okay, what if you kept going? What if you kept going past that house? And let's say, again, similar path. You started here. You went over here, visited somebody else. You went back. You're going to stop at home, but you know what? You just kept going. And you ended up back here. Now we need a way, this is the start, right? This is your start, and right here is your finish. Again, average speed doesn't matter, just kind of add up the total distance over time. But velocity here, we got to be careful, because now you're behind where you started. Your actual displacement is this way, to the left as we're looking at it. Now we need a way to distinguish you going to the right from you going to the left. So one of the ways we do that is with positive or negative numbers, forward or backward, to the right or to the left. Right? So your, again, displacement over time, and that's, again, delta x over delta t, the change in time, gives us our velocity. So v equals, let's say you moved back here, I don't know, 20 more meters. This distance is 20 meters, this distance was 50. All right, you've traveled 50, another 50, another 20. You've gone 120 meters, but your displacement is only 20 meters behind where you started, in the negative direction. Negative 20 meters. You did that in, let's call it 12 seconds. Again, making these numbers for the example as I go. So now your velocity is, I didn't pick nice numbers. So we go 20 divided by 12. Oops, try that again. 20 divided by 12 gives us 1.7-ish meters per second. Oh, but I forgot. This is negative, so this is going to be negative too. And why is it negative? Because you ended up behind where you started. Velocity doesn't care about the path, just the displacement over time. That's it. Cool? Cool.